SpaceX's Starship program is on the verge of a significant milestone with Flight 7, which might launch sooner than anticipated. While earlier NASA documents projected a launch date of January 11, 2025, disappointing those eager for a 2024 liftoff, recent developments hint at a faster timeline. Historically, the intervals between Starship flights have ranged from weeks to months, often delayed not only by technical preparations, but also by the intricate process of securing approvals from regulatory bodies like the Federal Aviation Administration, FAA, and the Federal Communications Commission, FCC. Following Flight 1 in April 2023, nearly 5 months passed before Flight 2 could launch, due to extensive investigations and infrastructure upgrades. The FAA's rigorous safety reviews ensure any issues identified in one flight are resolved before the next. However, recent FCC updates and SpaceX's accelerated hardware progress suggest Flight 7 could launch as early as December 2024. With objectives similar to those of Flight 6, the FAA's additional review requirements for Flight 7 are minimal, clearing the path for a timely launch. On December 4, 2024, the FCC updated SpaceX's launch license for Flight 7. This means there is now a chance for Flight 7 to launch in December 2024. Usually, FCC updates don't receive as much attention compared to FAA approvals, but in this case, the FCC's decision is crucial. The FAA focuses on safety, ensuring that launches don't endanger people or the environment. The FCC, on the other hand, handles communication during a launch. SpaceX needs to transmit data back and forth, such as tracking the rocket's position and speed or controlling different parts of the flight. The FCC grants permission to use specific radio frequencies for these communications. Without FCC approval, SpaceX cannot legally transmit this data, meaning the launch cannot proceed. Sometimes the FCC delays or denies a launch if the requested frequencies interfere with other critical signals, such as those used for air traffic, military, or emergency services. For Flight 7, the FCC's recent decision is significant because it extends the launch window from December 14, 2024 to June 14, 2025. Since the mission goals are similar to Flight 6, the FAA does not need to conduct another full review. This makes the FCC's approval the primary factor enabling an earlier launch. As long as SpaceX's final hardware tests go well, the FCC update makes a December 2024 launch possible. This is why the FCC update makes a December 2024 launch possible, as long as SpaceX's final hardware tests go well. SpaceX has made significant progress on the hardware for Flight 7, and preparations are moving quickly. Booster 14, the latest Super Heavy booster, completed its cryogenic proof testing in early October at SpaceX's Massey test site in Texas. This type of test involves filling the booster with liquid nitrogen to simulate the extreme cold of liquid oxygen and methane fuel, ensuring the structure can withstand the pressure and temperatures of a real launch. After successfully completing this test, Booster 14 returned to the launch site in Boca Chica, Texas. It is believed that SpaceX has since installed all 33 Raptor engines on the booster, a critical step before final testing. Each of these engines, capable of producing over 230 tons of thrust, will power the massive rocket off the ground. Ship 33, the upper stage of the Starship system, has also made steady progress. It returned from Massey's test site more than a month ago, likely after completing its own cryogenic tests and engine installations. Ship 33 is expected to carry 6 Raptor engines, 3 designed for sea-level thrust and 3 optimized for the vacuum of space. Before integration with Booster 14, Ship 33 must undergo static fire testing, during which the engines are briefly ignited while the vehicle remains secured to the ground. This test verifies the performance of the engines and the vehicle's overall systems. For Flight 7, SpaceX plans to execute a controlled landing of the Starship upper stage in the ocean and attempt to catch the Super Heavy booster using the launch tower's mechanical arms, known as Mechazilla. If this booster catch is successful, it would mark a major step toward making the entire Starship system fully reusable. The process of catching the Super Heavy booster involves guiding the massive first stage back to the launch site after separation. Using its grid fins, the booster controls its descent and slows down before attempting the catch. The Mechazilla arms on the launch tower are designed to clasp the booster just above its grid fins, eliminating the need for a traditional landing on legs. If successful, this innovative approach would simplify ground operations and allow for quicker refurbishment and turnaround between flights. If Flight 7 achieves its goals, it will set the stage for more ambitious attempts in future flights. Depending on how well the booster catch goes, SpaceX may aim to catch both the booster and the Starship upper stage during Flight 8 or another upcoming mission. Successfully catching both stages would demonstrate the full reusability of the Starship system, a capability SpaceX has long envisioned to make space travel more economical and sustainable. Reusability is key to SpaceX's plan to support high-frequency launches, deliver large payloads, and eventually send humans to Mars. SpaceX is already laying the groundwork for these future missions. Ship 34 and Booster 15 are nearing their final stages of preparation and testing. Ship 34 has completed its structural work and is expected to undergo static fire testing soon. Booster 15, which began construction in June 2024, has also reached the point where it is ready for testing. If everything stays on track, these two vehicles are likely to fly together in January 2025, maintaining the momentum SpaceX is building with the Starship program. Looking back at previous Starship flights highlights just how far the program has come. The first integrated flight, Flight 1, took place in April 2023. This flight aimed to get the entire system off the ground and into flight, but ended with the vehicle losing control and being terminated. Flight 2, in September 2023, improved on this by successfully separating the Starship and booster stages, though the booster's landing attempt failed. By January 2024, during Flight 3, SpaceX managed to land the Starship upper stage in the ocean, marking a step forward in reusability testing. Flight 4, in June 2024, achieved a soft ocean landing for the Super Heavy booster, while the Starship upper stage survived atmospheric re-entry. Flight 5, in October 2024, was particularly notable as it marked the first attempt to catch the booster using the Mechazilla arms. Although the catch was not fully executed, the attempt provided valuable data for refining the procedure. Flight 6 in November 2024 marked a pivotal milestone, successfully relighting a Raptor engine in space, a critical capability for future missions requiring multiple engine burns, such as lunar landings. Both the Starship upper stage and the Super Heavy booster completed soft ocean landings, signaling significant progress toward achieving full reusability. While the Starship program continues to evolve, SpaceX's Falcon 9 remains the gold standard for reusability. On November 26, 2024, SpaceX launched 24 Starlink satellites aboard a Falcon 9 rocket, celebrating its 400th successful launch since the program's debut in 2010. This impressive achievement highlights SpaceX's strides in achieving reliable and frequent launches. Notably, the mission also featured the 15th flight and landing of the same first-stage booster, showcasing the exceptional durability and efficiency of SpaceX's reusability technology. The Falcon 9 program has provided invaluable insights into rocket reusability, lessons SpaceX is now applying to the far larger and more ambitious Starship system. Thank you for watching, and we look forward to seeing you in the next video.